I'm given a function called p, where p of x is a cubic function, 7x cubed minus 8, and I'm told to find several things. For one thing, we want to know what the inverse is. Do that first. And then after that, we're going to talk about the domain and range. All right? So the inverse is found very simply by making a y equation. Say y equals 7x cubed minus 8. So we just write the original. And now we switch x and y. So this becomes x equals 7y cubed minus 8. And now we solve for y. That's it. So we add 8 to each side. This becomes x plus 8 over there on the left, and 7y cubed on the right. Now, I want to make a cube root to get y by itself, but I'm not ready for that yet. I need to divide both sides by 7. So x plus 8 over 7 equals y cubed. Now that y is by itself, I can take the cube root of each side. Okay, there's my cube root symbol on each side. And what do I get? I get y equals the cube root of x plus 8 over 7. Looks a little ugly, but that is kind of the nature of things when you're doing inverses. So now getting on to the domain and range. For this one, I'm going to talk about domain because there are two sources of domain restrictions. And if you know the domain restrictions, you can figure out the domain. Domain restrictions come from the fact that you cannot divide something by 0, and you cannot square root a negative. So the question you should ask yourself is, do we have any opportunities to divide by 0 in this problem? There's no fraction with x on the bottom. I mean, there is a fraction. If you look over here, we've got a fraction right there. But it doesn't have x on the bottom, which means there's no way we can divide by 0. Is there any opportunity to square root a negative? No, there's no square roots anywhere in this problem. There's cube roots, but those aren't the same thing. So that means no domain restrictions, which means my domain simply goes from negative infinity to positive infinity. And there's no interruptions along that number line. Now, once you have the domain, you can find range very quickly using this funny little characteristic of inverses, which is that the domain of P is the range of P inverse. Okay, the domain of P inverse is the range of P. So you can just copy whatever you put for those earlier ones and put them in the appropriate range boxes in the second half of this problem.